All right, let's take a look at number 11 in section 10.5. We're to determine the convergence or divergence of the given series. Now they have in parentheses or state that the test is inconclusive. Not really sure about this statement. I mean, I know we've been talking about the ratio test, um, and there is a case where the ratio or the root test is inconclusive, but if we're going to determine the convergence or divergence, we can use other tests to do that, and that's what we're going to do here. I'm not actually going to even use the ratio test. Um, in this case, because it actually turns out to be inconclusive. So, not really clear on the meaning here. But if I'm looking at this series from the top down processing, hopefully you would start with the nth term test, and this is a sub n, and clearly as n goes to infinity, all right, our a sub n's are going to go to zero, right? So the limit is zero. What's that tell me about this series? Well, nothing. Only that has a chance to converge. If this limit was not zero, we would know the series was divergent, right? Because I would be adding values that are, never going to zero all the way to infinity, right? Um, so what else is it's certainly not geometric. It's not a P series. It's not something I care to integrate, looking at it as is. Um, and yeah, they are positive term series though, right? For n equal 1 to infinity, this expression is always positive. So we can look at maybe a comparison test. So it is close to, P series. You can see you got 1 over 4 to the n, which would be 1/4 1 over n. And 1 over n, we know something about that. But there's also this plus, square root of n as well. So what are we going to look at? Well, the way I'm going to do this is to note that the square root of n, right? The square root of n is always going to be less than or equal to n for n equal to 1 to infinity. Certainly when n is 1, the square root of 1 equals 1. But when n is 2, the square root of 2 is less than 2. Square root of 3 is less than 3. Square root of 4, which is 2, is less than 4, right? And so this statement is certainly true. And so if that's the case, what I'm going to do is compare my terms, my a sub n's here to this, right? And I'm just going to basically sort of replace square root of n with n. And notice then, since the square root of n is less than or equal to n, then this denominator is smaller than this denominator, but that means this fraction must be bigger than this fraction, right? Greater than or equal to. Of course, they're equal when n is equal to 1, but for n equal 2 or more, we can say it's strictly greater than. So we have this bound, but what is 1 over 4n plus n? Well, 4n plus n is just 5n, which I'm going to write this way so that you could think of, right, if I look at this series and just factor out the 1/5, look at there, right? As we said, this is the harmonic series or a P series with P equal 1. It is divergent. And so we have a divergent series, we know. Our series, our terms are always greater than equal to the terms of that series. Therefore, by direct comparison, we know our series diverges. So there we go. I hope this makes sense on this one.